Okay, so we are doing some review for this big quarterfinal. And the quarterfinal, I'm dividing this up into 3 parts. And in my first hour class here, I'm going to be talking about the first 1/3 of the material. And I would definitely go look ahead of time and see which of these areas you may need to work on. If you bombed the Applied Quadratics test, it was the first test of the quarter. And frankly, if you're just going by class averages, this one was one of the toughest. This was the one I like second toughest, maybe. But those first 2, a lot of people need a retake on. So just to be clear on what happens if you did badly on one of those, and you take this quarterfinal and you feel like, you know what, overall I think I did like a B maybe, so I'd like to replace that F I got on the first test, then you just sign here, my initials there. You put your initials in there. But remember to only initial ones that were low, because if, let's say that you had an A on this test and you by accident sign in here, then I've got to replace it with this score. So if you had a B on the quarterfinal, you'd have to replace your old A with a B, and that's not good. So you really only want to use this for tests that you did badly on. So I really wouldn't be thinking about redoing an A. I probably wouldn't even think about redoing a B, just because the quarterfinal is kind of hard. You know what I mean? What if you get a B- on the quarterfinal and you replaced your B with a B-? Great. So it's not worth the risk to me, anyway. Unless I had maybe a low B, maybe C's, D's, I might think about replacing those. But only, again, after you've taken this test, if you feel good about how it went. Make sure you know which ones you want to replace. Yes?
Is it the overall grade or just for that section?
Good question. It's the overall grade for the test. So it's kind of good. Let's say that you weren't very good at complex numbers before. Let's say that you're a little better now, but you're not sure how well you did on that section. It's the whole test grade. So if you think as a whole, as this whole test, that you got like a B on it or whatever, then again, since it's kind of a hard test that you're going to take tomorrow, I wouldn't probably, strategy-wise, want to retake an A or a B. Definitely never retake an A. But a B, may not be worth doing unless you feel like you just rocked the test. Okay? So if you're going to get a B tomorrow on this test, then the only thing you should be replacing is C's and D's, or F's, right? And if you take it and you feel like, oh, that was really hard, well, maybe you only got a C on it, so the only thing you should do is replace your lowest grade, which was a D or whatever. And if you have all A's going, this was probably a very boring conversation, because you shouldn't sign any of the blanks, obviously. Yes, sir? It's going in out of 30 points, but then scaling down to well, bottom line is it'll be worth about the same as all your other tests, which is usually about 15 points, yes. So it's just worth the same as another test, but the magic of it is if it goes in backs and fixes old ones, that's what's going to make it really powerful. So it can't hurt you that bad if you do badly on this test. I mean, I suppose if you got an F on it, that would be really bad. But if you've got an A going on, we've had many tests. Well, how many have we had? 1, 2, 3, 4, 5. So we had 6 tests. This goes in, it's going to be 1/7 of your grade, I guess you could say. Plus, there's homework factored in, so it's even less than that. So, yes, sir. Yes, I am still planning on throwing out the lowest 2 homework grades, but I will warn you, the one that you're about to do today, it's going to be one of them. So don't think that today's homework is like just optional. Do it if you want to practice. It's homework. It's all assigned. I'm going to start that now, so let's do some together here and get some of your homework done together. So I want to talk over this applied quadratics stuff. You remember when we have an equation like this, that's the velocity? Does that ring a bell? And this part right here, what's that? Come on, say it if you know it. Y-intercept, also known as the starting what? Starting point, starting height. This is the initial height. This is the initial velocity. All right, so we've already answered question number 1. Just wants to know what's the initial velocity. All right, an equation for a projectile that has initial height of 7. Ooh, I just told you that's where the initial height goes. And initial velocity of 15. So you're just rewriting an equation. This part's always going to be the same because we're always going to do it in meters. And we're always doing it on planet Earth. And that's called a gravitational constant that's in meters. And therefore, you know that you can always start your equation like that. And one more thing, what if you didn't have a y equals at the beginning? You're going to get nailed for that. All right. Next up, cannonball is fired straight up in the air from the ground at a velocity of 200 meters. From the ground was important. What's the initial height? 0 if it's from the ground. So you write yourself an equation, just like last time. You start with y equals, or you could say f of x. And then you figure out the maximum height. Do you remember how the maximum height goes? Second, calculate max. Everybody take your graphing calculator out. I'll pause for a second while everybody does that. All right, so in the calculator, we need to get this equation in first of all. So let's actually figure it out together. It's y equals, what did I say we always start with? Negative 4.9. I'm going to use x just because that's what's in your calculator. If you just said a t, that'd be totally fine. And then an initial velocity, wait a minute. Yeah, velocity is next. An initial velocity of 200, wow, that's a big number, meters per second. And this is fired straight up in the air from the ground, which means it's plus 0. Do I really have to put a plus 0 there? No. I do need an x on this, though. 200x. Weird looking x. Try again. There we go. That plus 0 is optional. Don't have to have that. All right, get that in your calculator. Pause for a second. And while you're in there, go ahead and figure out the max. Hopefully you know how. Okay, I've got my calculator up here. And just a reminder, as one of the kids was asking about, if you have this thing in this mode, sequence mode, there's no way to put in my equation under the y equals. It doesn't work. So I go back to mode and get it out of sequence mode and into function mode. Hit enter. Then when I go back to y equals, it's back to normal. And I can type in my equation. Negative 4.9 x squared plus 200x. And then I don't remember what, oh yeah, it's plus 0. I don't have to put a plus 0, but I'm going to just to make a point. That is the starting height. Okay, then if I graph it, I probably won't be able to see it. If you think about it, it got really big numbers. You know what I mean? Like the velocity was really fast, so this thing's going to shoot up in the air really far. So I better figure out my window. I'm going to go to zoom 6 to start with, just to kind of get a more standard window. And that won't work either. I'm going to hit the window button and say I want to go way up. Is that x being big or y being big? That's y. It's y being big. I'm going to go to y max of, anybody help me out? What numbers are we talking here? Like 1,000? Higher than 1,000?
Quite a bit.
Like 2,000 maybe? Max? I'll try 2,000. And I'm going to hit graph. Now I can tell I didn't need that whole left side of the screen there. All right, so I'm going to try my window again. I'm going to say my x max and my x min. My x min, the smallest x, which is time, that I'm ever going to have would be 0. But I'm going to put -2 just because I like to be able to see the x's. My x max, I got to go higher than 10 seconds. This thing's going to be in the air a long time. This is real life. Like if you shot a bullet up in the air, if it's going as fast as we had it going there, it's going to be in the air way more than 10 seconds, maybe like 25 seconds. Let's see what happens. Holy cow, it's going to be in there for a really long time. All right, so I'm going to have to go to x max of, what did you guys say, like 50? And then y wasn't even quite high enough. I think I needed to go to like, holy smokes. All right, I'll go 3,000 then. That'll kind of be in between. You know, as long as you go bigger, it doesn't really matter much. Go big or go home. Good saying. Could be. Doesn't work in The Biggest Loser, but anyway. Okay, I'm going to go back to the window, and I got to make it a little bigger than 50. I think I have to go to like 55 or 60. Holy cow, that thing's going to be in the air for a full minute? Maybe not. We'll see. I've got it at 60 now, and yeah, I didn't need all of 60, but it's going to be like close. Okay, but how do I find the max? That's the top there. I go second, calculate maximum. Now, can you see why this part of the test takes you a long time? I've been farting around for so long just to get my calculator ready to go. Now I got to go left boundary, just get to the left of the top. Right boundary, I go to the right of the top. And then last is guess, and I get right on top of it, and I hit enter. And it says 25.6 and 2567. I hope it's obvious which one is which. Is this chickens versus time? What is this? Distance and time. And specifically, the distance part is what kind of distance? Height. So it's height and time. Uh-oh, is there something wrong? Got a different thing? I'm going to check mine. Did you have negative 4.9x squared? Is that correct? Okay, and then plus 200x. And let me just make sure there's nothing tagging on at the end of mine that I don't know about. Plus, yeah, look at that. I have an extra little thingy in mine. Thank you for saying that. Isn't that kind of scary? Because you would have probably thought you had it right, like I did. I had some extra junk in there I didn't know about. And I don't want 0 to the 4th. There's no reason for that. In fact, I'm just going to delete this whole term here. Come on. Why won't it get rid of the 4th power? Plus, thank you, 0 and, there we go. Okay. That's why mine looked different than some of yours, because I had extra stuff in my equation, and I apologize. Unfortunately, I can't re-record the video because I need to do different stuff in each class. So this is the hardest one, and I'm starting at first hour. It's tough. Okay, so now I'm going back to the maximum second. Calculate the maximum, which is the 4th one. And then I get to the left of it. And then I get to the right of it. And then I get right on top of it and hit enter. So there's a 20.4 and then there's a 2040. Do you get that one of those is the time and one of those is the height? You got to get it straight, because if you get them wrong backwards on the test, they'll be wrong. So the height, does it make more sense to you that the time should be 20 or that the time should be 2040? Time should be the 20. And it just makes sense because it's the x variable too. All right, and then the height, 2040 meters, that's way up there, by the way. It's over a mile up. Can you imagine if you shoot something at a fast enough speed, it's going to go up over a mile? That seems reasonable to me. It's difficult just to get something to go that fast, but all right. So we've got our max. Now, another problem in just a moment, they're going to ask us, I'm not going to regraph and do that problem for you. I just want to remind you, remember that spot where it hits the ground? That's not where it hits the ground. It's when it hits the ground. Very good. So that, do you remember what that's called? Second, calculate the what? The 0. Good. So we would go 0, and then you go to the left side of the 0. That's the x-intercept. It's way down here somewhere. I'm to the left of it now. Now I'm going to go to the right of it, which means past it. I'm going to hit enter. And now it's between those two spots. Get back to about approximately right on it. And that's close enough. And the 0 here is got y equals 0. That's the point. The height is 0, means it just hit the ground. And how many seconds? It took us 40.8 seconds. All right, so basically, this thing was in the air for a little over, well, it's 40 seconds, which is about, I guess, 2/3 of a minute, approximately. So that's a long time for something to be up in the air, actually. All right, I hope that's a good review for you of those kinds of things. That'll cover number 4 also. Let's go down and talk about 5 and 6 for a second. I'm going to clear the ink here. So if I take this and I want its maximum height, that's just another one of those graph it, find the max. And then the time at the maximum height, that's the other part of the max. So when you get that top part right here, you're given two things, the x and the y, and one of them's the time. This is the time, and the other one's the height. And remember to label them. If we decide, I don't know how we're going to handle labels, but if we decide to grade the units on it, of course, all you'd have to have is an m for meters and an s for seconds. Last kind we did not cover here is height of the ball at 2 seconds. Go second, calculate value. Very good. Everybody get back to your calculator and do that quick. Second, calculate value. What does it pop up with right away? X equals. So I got to tell it what the X is. What's X again? Chickens in Venezuela? What is it? X is what? Time. And the time is, I think they wanted us to put in 1. So I put in 1, I hit enter, and it says, little blinky thing. Here it is at 195 feet. So 1 second in, it's up 195 feet, which makes some sense because it was at a velocity of 200, but gravity's pulling down on it, so it's not going to be quite 200. All right, and then the last thing is this kind. The time the ball passes the wire. Okay, that's where this is a problem about a wire being strung across the gym. Okay, and if this wire is strung across, how can I make something go across this at a given height? You set another equation. Y equals whatever. So let's say I want to make y equals, in this problem, 500 feet. We want to know when this thing crosses 500 feet. So when I do that, I hit graph, and I see that there's now another line in here. And how do I tell which of these two spots was when it went past 500? The first one. This is the first one where it went past 500, but do you get on the way back down, it goes past it again? Okay. All right, so in this case, if I'm looking for the first one, I'll take that one. How do I do that? Second, calculate the what? Intersection, number 5. The intersect. That's where two lines are intersecting. Okay, and then the first curve, second curve, and if I just said guess now, it would jump to the one on the left. I don't want it to be on the one on the left. I want it to be on the one on the right. So I got to move my guess thing over so it's closer to the one on the left. There, now it'll jump to the spot on the left. If you look really close, you can see the blinking right above the N in intersection. So I can tell it jumped to the correct one. And that was at time 2.67 and height 500. That makes sense to you? That's not the correct answer for your worksheet because your worksheet's dealing with a different equation now, but that's how to do it on the calculator. All right, I need to cover basically 1/3 of this review. So far I've covered one of the sections. I'm going to now cover the next section, which is about complex numbers. Complex numbers is like the I-squared stuff. This was the second hardest test that you took. And let's talk about I and what I-squared and I-cubed and I to the 4th and I to the 5th is. All right. You remember that I comes up when you have the square root of -1? Do you remember that? So if I have I-squared, it's really 2 of these I's, which really is square root of -1 times the square root of -1. Do you remember what I-squared was equal to then? Close. -1. It seems counterintuitive because it's using these square roots of negatives, but you got to remember this whole thing's imaginary. But whatever you have a square root times itself, then it's whatever's underneath the square root will be the answer. So I-squared is -1. So if they ask for I to the 5th, do you get that that's like I times I-squared times I-squared? That's how you get an I to the 5th. So then this one's -1, this one's -1, and this one's I. So it's -1 times -1 times I. What if they've been asking for I to the 4th? If they wanted I to the 4th, you would say, well, that's I-squared times I-squared. And that's -1, and that's -1. -1 times -1 makes +1. So they have all kinds of weird little calculations you can figure out. That's I to the fifth, I to the fourth. How about I to the third? That'd be I squared times I. How about I squared itself? That's -1. We know that one right away. All right, good enough. So, how about this kind? That's just simplifying. Let's do that one together. Where do you start? 45. So you break that root 45 up into root 9 and what? Root 5. And also a square root of -1. Then two good things happen. This square root of 9 becomes 3. This square root of -1 becomes I. And then there's still a root 5 left. Is that the final answer? No. But that goes in there. And then do you get how there's a 6 and a 3 and a 3 that are all in common? I'll write it all correctly. 6 plus or minus I root 5. No, 3I root 5, sorry. 3I root 5 all over 3. And then whenever there's something here and here and here, you can cancel them. 3 goes into this twice, 3 goes in here once, 3 goes in here once. Final answer, dividing by 1 doesn't really matter, right? So your final answer is here, 2 plus or minus 1I, which is the same thing as I, root 5. So 2 plus or minus I root 5. Now, how did I know that this was imaginary? Because I had a negative underneath the square root. It's not like every time you have a square root, you have an imaginary. Be careful with that. One of the most common mistakes is kids think, oh, square root must be imaginary. It's only if it's a square root of a negative that it's imaginary. Okay, this next one, that's a simple FOIL problem. And I don't want to do it for you because I know you know how to FOIL. First, outside, inside, last. But at some point, you will have an I squared in the problem. Then what are you supposed to do? Turn it into a -1. So wherever that I squared is, you pull out just the I squared and you put in parentheses a -1 like this, wherever the I squared ends up in the problem. And then it'll simplify further because that'll make it easier. We put that on this year because there's something like just like that on the ACT test that comes up a lot where they'll say, you know, do this multiplication with I in it. And if kids that know that I squared is -1 can get the answer easy. You just have to multiply it out, swap out wherever you see the I squared, put in -1. All right, this kind of solving, and why would it be under the topic of imaginary? Look at number 10. Why is that going to become imaginary? Because the first thing you do is -25 on both sides, and you get x squared equals -25, and that is impossible. In the real world, you can't square something and have it equal -25. That's why you have to have the square root of a negative involved. So you're going to go square root, and then if you just say x equals I root 25, I will be very sad. Root 25 is 5. I would still be very sad because you've forgotten something really important. Plus and minus. Good. Oh, I did it. You're right. Square root of 25 is not the square root of 5. The square root of 25 is 5. So you're right. It's 5i. I'll do a little forging there. There we go. Thanks for catching me on that. It's too early in the morning. Okay, this next one. Start by subtracting 9 on both sides. Then you'll take a square root. Then you'll end up with this. Square root of -9, which was square root of 9 is 3. And then the I makes up for the fact that it was a square root of a negative. Did I go too fast there? All right. First thing I should have done is -9. And then I'd have x minus 2 squared equals -9. Then I go square root, and the square root of -9 comes out to 3i. This side, the square root of that came out to absolute value. Do you remember how that's what really happens here? This is an absolute value of x, and that's why you have a plus and minus. So then to finish this kind off, you split this up into two equations. One's x minus 2 is equal to 3i. And this other equation is identical to this one. X minus 2 is equal to 3i, but then you go back and put in a negative. That's the only difference between the two equations. Then you solve both of them. So you add 2 to this one, and you get 3i plus 2. And then you add 2 to this one, you get -3i plus 2. And that's it. Yes, you have answers that have an I in them. That's what makes them imaginary numbers or complex numbers. If they're got part of it's imaginary and part of it's real, That's when they're called complex numbers. All right. That is all I'm going to cover for this section. Now, if you want to learn the rest of these, you've got to watch the other two videos that I'm going to post, which are going to be about higher degree polys. And let's see. Well, it's just the rest of the test. I don't want to read off all the topics, but I'll start with higher degree polys in the next video. Any questions that kind of cover these other two topics? Yes? So for this one, you were asking the answer. You'll have two separate answers. One of them was 3i plus or minus 2, wasn't it? Something like that? Yes. Negative 3i plus 2 and 3i plus 2. Is that right? Don't do that. Those are different. Those are different. You don't ever want to say something like this. If it's got more than one term like this extra part on there, you have to write them as separate things. I know that may seem petty, but otherwise, it gets complicated, but basically you'd end up with different answers than you thought you had. So if you want to have positive 3i minus or plus 2 and then negative 3i plus 2, you got to write them separate. There's that answer, there's that answer. Any other questions about the first two topics that we covered there? Okay. Yes, sir. Oh, that's right. Okay. I don't know if the other teachers were really that tough on this, but I did tell you this a lot in class. That you're right. The imaginary part is supposed to come last. Do you guys remember that? So this should really be 2 plus 3i, and this one should be rewritten as 2 minus 3i. This is identical to this one. It's just rewritten so that the I part is last, and you're right. Thanks for reminding me of that, because I only get one chance to record this video. Those two should probably get swapped just because having the I part last here and last here is the proper way to do it. Thanks for reminding me. I don't know if we're going to grade for that or not, but it's the safest way to do it. That way, if we do take off a half a point for not reversing them, you won't lose one of those little halves. Okay, that's all I got for the video for this class.